Hello, my name is Mark Dale, and this is the second tutorial on how to use the Comet Bead Motility Simulator program. And here I'm going to show you how to use the three-dimensional isosurface generation, which is a good way to look at the densest areas of the network, which can show you the shape of the shell quite well. And so we're currently in a directory called Comet2, which is a directory where I've previously run through a calculation. And you can see if you look in the data subdirectory, it's full of files. First thing we're going to do is to look at the Comet parameters INI file, and we're going to make a couple of changes to that. So you can open this with any text editor, and you can see the format is basically a parameter name and then value. Parameter name and value. The first section of this, the first part of this, contains those parameters that are used in the calculations. So these things will affect the actual behavior of the network. For example, there's the shape of the nucleator, which in this case is a sphere. It could be an ellipsoid or capsule. There's sort of the force magnitudes and ranges, etc. And we talk about that in the supplementary materials, and we go over the robustness section, which goes through these parameters and varies them and shows the effect of varying them one by one. The second part of it is the display settings, and so these guys, the first section of the second part affects the way the bitmaps are displayed, all the way down to this part, and the second part of the second section is the VTK specific settings, and that's what we're going to look at specifically here. And so in the last tutorial, you saw a three-dimensional view which showed the links in the network, and that's controlled here. This viz links parameter, we can turn that off, and so we now are no longer going to plot the links in the network, and instead I'm going to turn on this viz ISO nodes parameter, and that's going to do an isosurface of the node density. And you'll also notice that there's a VXI scale, which actually tells the computer where to put the green isosurface, at what threshold of density. And that density threshold ranges between 0 and 255, so it's at 100 now. So what I'm going to do is I'm going to save that Comet parameters file, and then I'm going to start the Comet program, and say Comet view, and then I'm going to do a frame 220, which is shortly after symmetry breaking. And now it's going to read in the Comet parameters file, it's going to read in these settings, and it's going to do a three-dimensional visualization based on those settings. Here we go. And so as you can see, that what the computer's done is to create two thresholds for us. We have a green threshold, green surface, which is showing the densest areas of the network, and then outside of that we have a sort of semi-transparent grayish threshold, which is showing us a lower density and sort of gives us the extent of the actin network. But if we wanted to use this to show the shape of the shell, currently the threshold is a little bit low. In other words, the green area here actually is showing us, a relatively low density of the network, and we want to use the high density area in the center here. So what I'm going to do is I'm going to close this. I'm going to go back to this text editor. I'm going to change this threshold from 100 to let's say 220, and then rerun the Comet parameters. The Comet file after saving the Comet parameters file. Here we go. And as you can see, changing this threshold allows you to change the part of the network that you're sort of calling out here, and you can see that at a value of 220. You can see the shape of the shell quite well here. There's this sort of C shape with a sort of like dent in the middle, and you can also see in the grey network the extent to which the actin network extends. Okay, that's it. That's what I wanted to show you. And thank you very much for listening.